So good evening, everybody. Hopefully you can all hear me again. We have a few people here. I've started the recording, so I'm going to start off with welcoming everybody to the AACE Bruce County Local Section Technical Event for December 2022. We're going to have Shoshanna Fraizinger, who's the current president of the AACE International, going to be presenting us an overview of the AACE recommended practice cost estimate classification system as applied in engineering, procurement and construction for the nuclear power industries. So she'll be doing that once the cat gets out of the way. And I'm just going to start us off with a little video about AACE and why to get certified. You should be able to all hear the sound. If you can't, then please yell. Thanks very much for taking the time to watch that with us. So without further ado, I'm going to introduce myself. I'm Robert Ayres. I'm the president of the local section. I appreciate all of you joining us tonight. And we'll a couple of matters of protocol. Please, I'll be facilitating the discussion tonight. So if there's any questions, please use the chat feature. I'll be monitoring the chat and I'll interject as required if you have a question you wish to ask Shoshanna. And I do encourage participation if you can. We are recording this, so this will be made available to the participants after the event once we've formatted that and put it on our YouTube channel. So without further ado, I'll turn it over to Shoshanna for her to introduce herself and kick us off with this evening's presentation. Thanks, Shoshanna.
Thanks, Rob. Can everybody see my screen? Brilliant. Okay, so this is an overview of recommended practice 115R-21, the cost estimate classification system as applied in engineering, procurement, and construction for the nuclear power industries. It was originally presented at the 2022 Conference and Expo as EST 3795. So if you happen to purchase the transaction recordings, that's the number. But this particular one has been tailored for us. So a little bit about me. Currently the director of the Bruce Power Project Services and Program Support contract for Sargent Lundy. I'm also the president of my own consulting company. I've sat on both sides of the table as an owner and a vendor, and I've got over 25 years. I shouldn't really admit that, primarily in the Canadian nuclear industry. In engineering projects and construction management. I've been a member of AACE for about 8 years, and I've got CCP and PMP certifications. As Rob said, I'm currently the president on the board, but there's a long list of other roles on Bruce, both Bruce Power section and the VP Education, etc. So let's actually talk about the recommended practice, which is why we're here. I'm one of many contributors for this particular recommended practice. And it was quite interesting to actually be part of this process and see how rigorous the technical board actually reviews this information. So what's the purpose of this? Well, this is a new recommended practice, and AACE likes to make sure that people are aware of new recommended practices. And because Bruce local section primarily supports vendors and owners in the nuclear power industry, it just makes sense to have us talk about it here at a technical event. So we're going to talk about why this particular recommended practice was written, how it's structured, what it is, what it isn't, and really highlight some of the differences from the recommended practice many of us might be more familiar with, 185R-97, which is cost estimate classification as applied in engineering, procurement, and construction for process industries. And we'll talk about use cases for this RP. So let's actually go back a little bit and talk about, the purpose of an estimate classification. It's really about mapping the phases and stages of the project cost estimating together with the generic project scope definition and maturity matrix that comes with project lifecycle and gating that can be applied across a wide variety of industries. Now that definition is taken out of sort of the source classification system, 115R-97. And as I said, it's really generic for any industry. However, we all know that different industries have different nuances. And so over the years, a number of industry-specific variants have been developed by AACE, some for mining and minerals, some for buildings, hydropower, et cetera, transmission and distribution, and the list goes on. And the reason why people have done this is because the generic is not necessarily a one-size-fits-all really well. And so you want to make sure that particularly when we're talking about accuracy and the different types of deliverables that are created through a project's life cycle, that we understand what we're all talking about. And in some cases, some industries have such interesting nuances that it's worthwhile to put out a specific industry variant. So the nuclear industry has typically used globally 185R-97 as what they're relying on to develop their cost estimate classifications. And we're going to kind of walk through why this particular RP 185R-97 doesn't always work. There are some specific nuances to nuclear CapEx projects that really show it's not really just another process industry. We employ a broad range of technologies defining overall design. And again, we're talking about global nuclear projects, obviously beyond just the can-do that we're familiar in Bruce Power. So each of these different designs have their own flavor of nuclear safety considerations, which many of which means that we have redundancies of system structures and component elements, which you wouldn't normally encounter in other types of process industries. They also typically have a very significant regulatory and licensing requirement, and that can happen throughout the project lifecycle. This really translates into labor and paperwork deliverables that are, again, well in excess of what you would normally see for, standard environmental assessments or operating licenses for other types of process industries. And as we talk about refurbishments or aging plants that are dealing with license renewals, we may have to address obsolescence or changes in the OEM manufacturer when we're dealing with OEMs that have stopped producing certain components, or worse, they've been bought out by somebody else, and through that process, the design and manufacturing specs for that original item has kind of been lost. It really means that the nuclear industry is dealing with projects that have to, in essence, reverse engineer items to fit a specific safety or performance function. And again, that really translates from a cost perspective into R&D, and that's not normally experienced in other process industries. So the trends in costs have significantly varied in magnitude and in structure by era or country or experience. For example, in contrast to a lot of the rapid cost escalation that are characterized by nuclear construction in the US and Canada, we can find evidence in a lot of the background for other projects globally that there is much milder cost escalation in some of these other countries. So, and in some cases, we actually see an absolute cost decline in specific cost areas or in specific countries. So it's rather interesting when we're talking about trends in nuclear projects, that it's not, again, a one-size-fits-all from a perspective of benchmarking. And of course, speaking of benchmarking, because nuclear projects often have non-proliferation aspects associated with them, when we're talking about, finding that historical information for, that we typically rely on to develop our cost and schedules, it can be harder to find and harder to validate. So we have a whole host of different types of nuclear projects that we might consider. New build projects are primarily a subject of this RP, major refurbishment projects also. And then we consider, the major system structure component mod projects. So we're not talking about a full refurbishment of a reactor unit for license renewal, but a major modification. Or maybe we're talking about modified or new reactor tooling, fuel waste handling, storage, specialty tooling, R&D, and decommissioning and remediation. When we're talking about modifications, again, and I'm probably preaching to the choir here, we're talking about projects that intend to change the form, fit, or function of that system structure component with such significance that we have to have a design package. So what we're not talking about is, a project where we're changing out valves or something where essentially we're looking for item equivalencies, or projects where we're disassembling a turbine for rotor rewinds, as in the case of a maintenance program. So any projects where we might have inspect, calibrate, clean, swap, or test in the scope is also not really the type of project we're considering in this RP. However, there are RPs that do talk about maintenance turnaround, and I would reference those ones because they might be more applicable. So all of that can affect the cost considerations for nuclear projects. There are some very specific cost considerations, obviously regulatory reviews, requirements for licensing. This includes nuclear safety analysis, the defense in-depth design where we might have duplicated, triplicated lines, indications, and enunciations. This means more piece parts that have to be procured and designed, and all of that costs money. Again, unique codes and standards, EQ, pressure boundary, seismic, all of those don't really exist in what I would call the real world projects. And then, of course, the pedigreed procurement, a tube of, Loctite in the normal world could probably be bought at Canadian Tire, but we can't do that in the nuclear industry, depending on where we're going to use it. And so all of that, again, costs money. And then the project planning worksite location, oftentimes, as we know in Bruce Power, where, in fairly remote locations, it can be difficult to try and find trades and resources available and willing to go, particularly if we're talking about new projects with remote areas where we need campus planning as well. And of course, we've got more complex hazards and safety response requirements than, again, the normal conventional safety considerations in a process plant. When we're talking about our, ALARA requirements for radiation safety, all of that requires time and money, and that comes at a premium oftentimes. So what can we conclude typically we have not been very good at managing our costs historically, and costs have been the primary issue facing the nuclear industry over the last 20 years. And so that kind of drove us to understand that perhaps maybe RP 185R-97 might not necessarily be as adequate for the nuclear project cost estimating in all use cases. Oftentimes, when we've gone through projects in implementation, there's a schedule and cost growth. And of course, the first statement is, well, the estimator got it wrong. They didn't know what they were doing. But maybe, in fact, that wasn't necessarily the case. We were working with accuracy ranges defined by an RP that didn't necessarily fit the whole bill, so to speak. So what have we seen? New build projects are obviously at most risk for cost growth. I'm probably not surprising anybody by saying that. And this is primarily because nuclear projects have been very uncertain, and the costs have increased significantly over the last few years. And where we've seen previous overnight costs for new builds in the range of, $1,200 to $1,500 per kilowatt. These have been increasing as late as 2003 to be closer to 2,000 per kilowatt. So you can imagine if we were looking at 2020 or 2022 values, what those would be. But again, because we don't necessarily have the best benchmarking, this was as close to the current state of the calendar as we could get for some of the background detail. But we also know that not even refurbishment or mod projects are immune to cost growth. So recent reviews of some execution phase estimate submissions actually indicated that the growth for these types of projects have reached as high as 380% in the cost presented as compared to the original submission. And that's important because we also have this bad habit of doing a comparison of estimates gate over gate, when in fact what we should be doing is talking about the current iteration of the estimate as compared to the original submission. The original submission should represent the whole picture. And as we move through each gate and we better define our deliverables, we are basically right-sizing the composition of costs within the box, as it were. What is base, what is contingency, what is EU? But sometimes what we have is we're comparing it gate over gate, and that's not a real true reflection of what cost growth looks like over the life cycle of the project. So why was a nuclear specific variant required? Well, let's look at the future of nuclear industry. We've seen that currently the global energy generation has increased since in 2021 as compared to 2020. We also know that the current energy generation levels are not on track to keep our global decarbonization targets, and we're going to need to increase our capacity. More countries are actually recognizing the need for nuclear power in their energy mix. The World Nuclear Organization says that there are about 440 nuclear power reactors operating in 32 countries. That represents approximately 10% of the world's global electricity. There are about 60 power reactors currently being constructed in 15 countries, and that represents another 26% growth in our global nuclear capacity by 2050. So what that means is nuclear is not going away. And in fact, as we recognize that it is a cost competitive option for providing energy to the mix as compared to, say, somebody who has easy access to a carbon type facility, it becomes more economically palatable. we want to make these better estimates. We want to make sure that the economic basis for deciding to go nuclear is maintained throughout the life cycle of that project. Remember, the whole point of projects is to make sure that the originals, organization strategic asset planning is those objectives are met, and making sure that the projects meet the return on investment is part of that mix. So, as we also see that most nuclear power plants that were originally, designed for a nominal operating lifetime of 25 to 40 years are now going through engineering assessments to operate longer. Again, we're going to see more refurbishments. At the end of 2016, CNSC had granted license renewals for life extension to both, OPG and Bruce Power for reactors at their sites. But the NRC also granted license renewals for over 85 reactors to extend their operating life cycles from 40 to 60 years. So, this licensing renewal justifies that significant capital expenditure to replace all of that worn equipment. We need to make sure that as we are developing the project documentation, moving through that project life cycle, that we continually maintain the justification in cost and schedule that the ROI is going to be achieved. So we need what we understand is there is an impact to our capital planning and costing. We have to recognize that we have some lessons learned. The cost and delivery challenges for nuclear tends to be underestimated. Again, I'm probably not surprising anybody by saying that. And that's due in part because we haven't had an adequate estimate classification system. So, how is this RP different from 185R-97? It's really addressing the gap for nuclear. It talks about some very specific industry basis for engineering, procurement, and construction work, such as the required licensing and regulatory requirements. And the data and ranges that are provided in the RP has been globally benchmarked against project data from the nuclear industry in Canada, the UK, USA, Japan, France, and Russia. The types of nuclear projects considered is also new. We talk about that, and it addresses the nuclear specific planning and execution requirements. So there's a right sizing of the range of accuracies. So the RP provides guidance to both owners and service providers, vendors, and it supplements, the generic cost estimate classification RP 115R-97 by providing an additional section that provides some further classification concepts and definitions as they apply specifically to nuclear, and the specific differences in nuclear as opposed to other industries. It also discusses some of the specific quality assurance and regulatory requirements that might influence cost. It has a section on some of the general guidance regarding the application of productivity factors applicable to labor quantification that's specific to conducting work in nuclear power projects. And it provides industry-specific deliverable guidance regarding the maturity assessment and estimate classification characterization. Remember that classifying an estimate is really based primarily not on what the project manager or the owner has said they want the estimate classification to be. The estimate classification is based primarily and foremostly on the level of definition and maturity of the project deliverables. And so this helps take some of the ambiguity out of correlating the listed deliverables in the generic or 185R-97 matrix and gives you some very definitive nuclear guidance and nomenclature. So project applicability and use cases, what this RP is and what this RP is not. So this recommended practice, it's applicable to nuclear CapEx projects, including new build, including small modulars, refurbishments, major mods or mini mods, new or modified reactor tooling, and significant building construction directly part of a fuel cycle. We are not talking about, again, item equivalencies. We're not talking about maintenance. We are not talking about waste and decommissioning in this particular RP. So it does not account for transmission and distribution. That's a separate RP. No waste management, no decommissioning. R&D is also outside of this RP, mostly because these are almost, what they call class 10 type estimates, where there is no real basis, but there is now a defined approach, and that's discussed in a separate RP. Nuclear fusion reactors are also not covered, although I understand they are in the news this week, which is excellent. And fuel enrichment, reprocessing, or disposal, not included in this RP. The important pieces of this RP include the accuracy ranges. Now, one of the comments that came in during the peer review of this RP was that these accuracy ranges were in excess of what had already been used in different organizations, and it was very difficult to have management agree to having a range that much wider. In essence, they felt like we were giving the vendors a blank check to be able to ask for a whole lot more money. No, again, just like every other industry-specific variant, the use case of these needs to be right-sized based on your historical applications. Your own internal historical database is your best source of benchmarking. So remember, accuracy is a measure of how close the measurement is to the correct or accepted value of whatever it is that's being measured. It has nothing to do with precision, which is how often the series repeats itself. So when we're talking about accuracy, it's not that it's repeatable, it's that it's the most correct. And to be the most correct, or the most accurate, you really want to have an estimate that is risk informed. So this is the new table in this particular RP. And for the estimators on the call, you'll see that these ranges are significantly different at the class 5 and 4 stage as compared to what you've previously seen, actually all the way through. That plus or minus value represents the typical percentage of variation at an 80% confidence of actual costs from the cost estimate after we've applied appropriate contingency, typically to achieve a 50% probability of project cost overrun or underrun for a cost overrun for any scope. That's important because this is also something that is in line with our generic RP as well as our other industry variants, but often misunderstood. And so when people look at this without understanding that the expectation is that that range includes contingency, it is not exclusive of contingency, that can be a difficult conversation as well for some. Depending on the technical and project deliverables or other variables and the risks associated with each estimate, the range for a particular estimate is expected to fall within the accuracy ranges identified here. However, this does not preclude that the actual project result may fall inside or outside those indicated ranges. The dependency on this is really about the quality or completeness of the technical and project deliverables, and the risks associated with the estimate. So in addition to the degree of project definition, the estimate accuracy is also driven by a number of systemic risks, including the level of new technology in the project. If we are doing a rinse and repeat of series of scopes where the technology is the same, it's well understood, then obviously you're going to be well under the accuracy range depicted versus something that is brand spanking new. If we are talking about unique or remote natures of locations or the conditions or the availability of the reference data for those things, then again, we'll have a wider range of accuracy. The complexity of the project and the execution of that project, the quality of the reference information for your cost estimate, and the quality of your assumptions used in preparing the estimate, as well as the experience and skill of the estimator. So if you include, if you've got some bad assumptions, obviously garbage in, garbage out. But if you have somebody who doesn't recognize that they've been given garbage in, that may also contribute to garbage out. Then, of course, the estimating techniques, as mentioned, I'm just going to go back a little bit here. Each of these different estimate classes has an associated methodology that is expected for how you're going to develop that estimate. If you are an estimating group who always estimates the same way for every single class, you might need to look at what you're doing and the expectations that are being placed on the organization for why you're doing it that way. The level of effort to produce a class 5 estimate may not be the same as producing a class 2 or a class 1. And so, of course, the time and level of effort budgeted to prepare the estimate, if you've got a class 1 estimate or a class 2 estimate that is, you've only been given a week to turn around, you might not have the best estimate at the outside, and your accuracy may be off. The market and pricing conditions, of course, the projects that we estimated back in 2019 have not come in with actuals in 2022 as we thought they would. And again, our estimate was not accurate. Currency exchange, also an issue. I had the benefit of being involved in a project where we were producing a class 5 estimate with resources in Canada for a US company supporting a project that was out in Europe. Currency exchange, assumptions, reference data, all of that came into play and was rather interesting. Again, if we document everything in the basis of estimate, at the end of the day, somebody will be able to read what we've done and understand why we did it and be able to understand, was this accurate at the time, or were we out to lunch when we put those numbers together? And then, of course, the level and skill and effectiveness or cohesiveness of the project team. If the team is not operating as an effective team, communicating with the estimator, then not everything about what's happening on the project is going to go into your estimate, and that means it's not going to be accurate. So these are a few of the systemic risks. These are often the primary drivers of the accuracy, actually, especially during the stages, the early stages of project definition. But as project definition progresses, the project-specific risks, those risks and events and conditions that we list off in our risk register, these become more prevalent. They also start driving the accuracy ranges. Another concern, as I mentioned, in estimates is the potential for organizational pressure for the estimate to achieve a predetermined result. that will ultimately result in a biased estimate. And oftentimes it's optimistic. It's a low number, not a high number. And the goal should really be development of an unbiased cost estimate so that it's an objective estimate for both base cost and contingency, so that the project team can then take a look at that and understand how to adjust their contracting or execution strategy, how to understand what may be influencing that they may change. But if we try to force fit the number into a box, we have removed our ability to assess it properly. And if we've removed the ability to assess it, then we've removed the ability to make decisions about it. And that's, I think, the biggest risk for accuracy that I have seen in most cases. So what we really want is a realistic view of the project, and the stated estimate ranges that are included in this RP are dependent on this premise that we are providing a realistic view, unbiased and objective estimate. So if we fail to appropriately address systemic risks during our risk analysis process, this will impact our probability as a distribution for the estimated costs. And if that's happening, then we're affecting our interpretation of estimate accuracy. And what I mean by that is, if we haven't thought about all of the systemic risks, we are being overly optimistic in our view of the estimate, and will probably have a narrow range applied to it. And that may not necessarily be the case. Conversely, if we've, as I said, have something that we've done before, we really know how to do this, we do this well, this is like so in our wheelhouse that we can't even find the walls of the house, then we can consider that something that doesn't have a lot of risk, and the accuracy can obviously be much finer. So we could in fact say we're producing a class 3 estimate at a point in time where we might be considered to be developing a class 5 earlier on in project development. We know a lot. Here's where we kind of need to really think, because the fact is, research has indicated for weak project systems or complex or otherwise risky projects, the higher ranges may actually be 2 or 3 times higher than the high range indicated on the table. In fact, one study for nuclear project cost growth and schedule slippage indicated that the need for contingency set at P50, including all our risks, was approximately 70%. And at P90, we were looking at greater than 200%. So what that means is, if we were looking at something that was class 3, it would actually be 3 times higher than the note on the table, which is quite disconcerting, because what we really want to do is remove the uncertainty, right? Make things more accurate. If we can make things accurate, we know that we're going to have our return on investment and meet the strategic objectives of the organization, which is the whole point of doing projects in the first place, not just to keep us employed. And in the case of minor projects or minor modifications, repetitive, as I said, accuracies may fall well in the bounding cases of 185R-97. In those cases, it might be perfectly appropriate. So the key takeaway for any organization is to assess their own historical database, right-size the guidance provided in estimate classification RPs, and where the risk profile of the project warrants, apply the right level of conservatism. So let's take a look at the deliverables maturity matrix, which is the basis of classification assessment for any estimate, as I mentioned, specifically in this RP. So as you can see, we've included things like regulatory and licensing, permit conditions and requirements and conditions. So for example, at class 5, we expect these to be preliminary. But at class 4, where we expect 1 to 15% of our overall completion, and again, this is engineering completion, and you can see at class 1, 65 to 100. That means we're including our construction work packages. We're including our field engineering that is required to support execution. Oftentimes, organizations make the mistake that once I've completed my detailed design, engineering is 100% complete. No, according to AACE, at best, you are probably only 40% complete. And again, that's something we need to consider. Regulatory licensing at class 3, we expect that to be fully defined. We know exactly what's happening. And again, just a couple of other ideas, obviously, understanding what our plan is for fuel and waste management, and not required at class 5, but we expect that we would be preliminary at class 4, developed at class 3, etc. Our site infrastructure, again, not necessarily required at class 5, but we would expect to have this preliminary at class 4, etc. So that would be sort of our general project data related to scope. And this is just an extract. It is a fairly extensive nuclear deliverables maturity matrix. And I actually spent about 3 days with the tech board reviewing every single line item with a full interrogation on why this was included, why this was specific and necessary for this particular nuclear RP, and how it was different from what had been listed in 18R97. So when we talk about planning, again, we've included you'll see some things that are similar, such as our project master schedule and estimate, the code of accounts, etc. But then you'll also see some new things like the permitting plan, licensing and regulatory, the ALARA and dose control plan. All of these have been tailored to project deliverables and project phase gate planning that was identified from various different companies across the globe. And what I can tell you is it was a wide range of global companies, all tied to nuclear power industry, as well as some academia. It aligned to the requirements of an international suite of published references, codes, and standards. So we made sure that we touched on not just CNSC in the case of Canada or CSA. There were multiple private company and public practice standards solicited and reviewed for incorporation. All of them were actually found to have some significant commonalities, which was quite reassuring, and supported by our nuclear power academic professional research of systemic risks in correlation with cost growth and schedule slippage. So from the perspective of references, we had many, and I've listed them all here. And with that, I'm going to turn it back over to Rob, and we can see if there are any questions or comments or chat.
No. That is, no, there hasn't been any questions yet. Any questions? Anybody? Did a wonderful job. You either did that or you put them all to sleep. So one of the challenging thing, I have a question, and I'm sure Mr. Hindle has similar questions, but how do you accommodate as found conditions in your estimating? One of the things that challenges us a lot is we go and design a modification in a plant that was designed 30 years ago, and then you know that you have a feeling that the as found conditions or configuration control hasn't been the greatest.
Yeah.
And then you go and execute, and it really does create an additional cost to a project when there's a bunch of additional work to be done because of as found conditions not matching the paper plan.
Yeah. So, and actually this topic came up quite recently. It's a good example because again, going back to, the total approved budget. Let's use that as the basis. The total approved budget needs to include your base cost. That's the scope in your scope of work, and the scope as let to the vendor for what they're going to do. And then you supplement that with your risk register, which is, I think I'm going to have some as found conditions. And if I have as found conditions, it might include situations like, buried piping, or, services that were not on drawings, or, significant, geo issues with respect to installing a new foundation, whatever it happens to be. And you're going to make that assumption based on your historicals. What have you seen before as potential as found conditions? And you're going to build in some kind of base cost for mitigating what you know. So if you typically find that you run into, buried conduit or broken piping that needs to be replaced, if you have some general costs associated with those, you'll pop that into your response plan, which actually becomes part of your base cost. However, that may be off. And so you're going to carry the amount of uncertainty about your mitigation plan costs in your base in your EMV. So effectively, the risk register would look like this. There is the potential for as found, which may mean I may have to have additional labor and materials to address this. Historically, it's been Y, and you include Y in your base cost. However, if that's the cost for your mitigation response. However, that may be wrong. And so you're going to carry EMV to account for the amount you might be wrong by. And then you would access that through change management. So you kind of carry a little bit of it in your base cost. The trick that a lot of people are not very good about is how do you release back that portion of uncertainty or EMV back to the organization after the risk has transpired or passed. So if you've gotten past the preliminary field installs and you realize, oh, actually your as founds weren't as bad, or they were right on target, and you've hit your mitigation response did exactly what it was supposed to do, you can return back that EMV that you are holding in your total approved budget back to the organization so somebody else can use it, right? Okay. So that's how you would do it.
Okay. So I've got some questions now. People have woken up. So
awesome.
This one here, is there any specific difference between oil and gas refinery, petrochemical plant, and the nuclear plant?
Right. So in a nuclear plant, there are a lot of similarities. The biggest difference, obviously, is the reactor itself, and the productivity factors that are required to adjust for working in relation to the reactor or any safety-related systems. And so the safety-related systems don't necessarily have the same requirements as they do in oil, gas, refinery, and petrochemical. So for example, there are seismic standards or environmental qualification standards. And by environmental qualification, we're not talking about, were we green today? What we're talking about is the assurance that safety-related component can perform its safety-related function regardless of where the plant is in its life cycle. And so with that comes a lot more pedigreed paperwork. It's a much more robust item. There are specific installation requirements. And so those would be the specific differences that would be different. I would argue that the oil, gas, and refinery petrochemical plant is probably more more applicable or more associated to the 18R97. With the comms, yeah, you're welcome.
You've got the chat up. You can
I just got the chat up. Yeah.
Ask and answer your own questions.
Yeah. The comms team walkdowns as well as the estimator walkdowns help with this as well. Scott, I'm actually going to ask you to add a little bit more nuance for me, because I don't know what I was talking about when you wrote the question.
So that was sort of a thought on Robert's question about as found conditions.
Yeah.
And I think the constructability team plays a key role in that. When they do very good walkdowns, they sometimes find these as found condition gremlins ahead of time, so that really helps. And it's always beneficial for project teams, field engineering, the estimator of a specific project, get out in the field. That's kind of where all the answers are.
True. I highly recommend both the designer and the estimator get out into the field and take a look at what they're doing. And that's not just because I used to work for a company where designers designed the HVAC system backwards to plant configuration. But there are some things that you just physically can't see,
My point was, Scott, I get where you're coming from, and my point is there's stuff that we can't actually get to.
Yeah,
100%.
Right, and it's things that bite us because it's been changed in the past to fix a problem, and it's not documented. So that's where I was coming from. So thanks for that.
Yeah, and I mean that is obviously a case for good configuration management, but when you're talking about a plant that is coming up on its 40 years and they're looking to do a dust and polish to give it another 20, that paperwork may not necessarily be there. I mean, I remember when I started at Bruce in 2001, most of what was known about that plant was written on the side of somebody's filing cabinet on a napkin, because they just knew that's how it worked, because the design manuals were back in the 70s and had never been updated, and there were a bunch of jumper cards sitting in a desk drawer in the INC INC that never got updated. So unfortunately, when we're dealing with plants that don't have consistent configuration management, and arguably because of what nuclear is, we probably have some better configuration management, much to the contrary belief of most of us working in this field. But there are just some things that even so, you just wouldn't know, you wouldn't see.
Shoshanna, I think the key your message there was good risk management.
Good risk management, correct.
Right? I think that's the point here. Is the estimate can be as good as it can be, but if you've identified a risk, make sure you quantify it and understand what you need to carry forward. And I think that's something we need to, every industry needs to get better at. So
yeah, that's right.
Move on to the, sorry, I just want to move on to the next questions, right? So next one is from Aaron. How is the range within low and high determined? For example, class 2 estimate high is 10% to 40% rather than just 40%.
Right. Well, so AACE never likes to talk about just a specific number. It's a range of ranges that we talk about, because it's never one. It's never one estimate. It's never a point. It's a possible series of outcomes, and you're hoping to pick the best of them. And typically what you find is, organizations will hit on the 40 because it is obviously the most conservative, right? 10 to 40. If I'm asking a senior program manager for money for my project, and I say 10, but I end up needing 35, I am going to go, oh, I should have asked for 40. The point of it is, it could be as low as 10 and it could be as high as 40. It really depends again on, the strength of the organization in terms of being mature with respect to how they handle risk in assessing costs, how they plan their projects, and making sure that they have a risk-informed estimate. If you have a risk-informed estimate, one that has response plan costs in the base and have got valid EMV attributes to the risk register and a right-sized amount of estimating uncertainty, which needs to be separate and distinct. It's an additional layer of contingency over and above your risk-specific items that handle things like, oh yeah, you know what? The configuration management on this system was even worse than the last system we were working on. Or I have a new vendor and I don't really know how they operate. Whatever those systemic type risks are, those more nebulous, you're going to include estimating uncertainty for. How and estimating uncertainty is effectively, the estimator's gauge of how good the input they got was for them to be able to come up with an accurate estimate. If the project team doesn't write a good scope of work and the estimator has to start making some fill in the gap assumptions, their assumptions could be wrong. How wrong will be covered by estimating uncertainty.
Thanks, Shoshanna. So next we have Victor. This RP is very specific to nuclear. Is it typical or atypical that RPs are customized to an industry? So Victor, you may have missed the introduction here. I think you joined a little bit late, but Shoshanna, can you just recap the evolution piece that you covered at the intro?
Yes, I could. So there is the starting point was recommended practice 115R-21, which was the generic estimating classification system. However, it's been understood that there are a number of industries that have some nuances that take it so far outside of generic that we would want to have some more discrete and tangible guidance for how to perform estimate classification in those industries. A good example is pharmaceutical. Their projects run very differently than the rest of the world. Transmission and distribution doesn't work the way normal CapEx projects do, in that they're very linear, right? And so for mining and minerals processing, again, has some very specific considerations in terms of scope and risk and costing that they warrant their own recommended practice. And this recommended practice has been a subject of consideration for about 5 years, where we've said, you know what, there are enough nuances that are different in nuclear that RP 185R-97, which has primarily been used, doesn't quite fit the bill in all use cases. And so as we sort of see that nuclear is becoming more on the up and up as an energy source or source of energy, that this was thought to be the time is now for this RP.
Thank you.
Welcome.
Thanks, Victor. The last question I have, and people please add more, is from Gregory, is how to address the current labor and material cost escalation in old estimation we are having. Some use Some of current use estimation has been approved back to 2019.
Yeah. So, I mean, in an ideal world, if you have all the time and resources, what you would do is you would do the proper material takeoff. And I'm assuming we're talking about, you know, a class 3, a class 2 estimate, rather than a class 5 or class 4, because you would handle them kind of differently. So if we're talking about a class 3 or class 2, you would really want to go out and resource costing for that particular item. But let's say you don't have the time for that, or let's say you're working on a class 5 or a class 4 estimate where you don't need that fine a precision on the cost input. Then what you would do is you would go into what is recognized in your organization. Thank you, Gregory. You would go into what your organization's normal financial practices are for escalation and inflation, and apply those. So oftentimes what you might do is you would go back into the Bank of Canada. They've got the full consumer price index values month over month, year over year. Most companies use consumer price index. It's not, again, the most applicable to nuclear because we're not, buying, women's clothing or milk, but however, that being said, CPI is generally what we use in our industry. And so you would go back and you would actually take it and inflate it using those numbers to current year of dollar, and then use that. And then separately, you would talk about moving forward for your future, cash flow. Yes, gold price is pretty good as something. The problem is if your organization doesn't actually escalate that way, then you're going to be out of sync with the rest of your the financial assumptions of your organization. And remember, your project doesn't stand alone in isolation just to make sure that you're employed. You're welcome, Gregory. Your project is there because the organization made a strategic decision to say, this is going to be good for the organization from a portfolio point of view, and we're going to see some return on investment. And obviously the levelized cost of energy is typically the gauge, the metric by which nuclear projects are balanced on. And so we're looking for the right rate of return. And if they're making, the strategic planning decisions based on CPI and you're doing it on gold, then it's going to be a little off.
Okay. I don't see any other questions there, Shoshanna. So
Welcome.
number of thank you. So I think are we wrapped up now at the end of our evening, or is there any final questions? Speak now. I don't see any more questions. So on that note, I appreciate your time, Shoshanna, and we'll definitely capture this recording and send it out. We did have over 40 odd people register, so obviously people are expecting to get the recording. We'll have to charge for that, I'm sure. But I appreciate everyone joining us tonight. If there's any follow-up you'd like to, just email straight to our email site. I just want to close with saying, again, thank you to Shoshanna, but secondly, please have a good holiday season and be safe, and we'll look forward to seeing you in the new year. So thanks very much. Have a good evening. Thank you.